Ma'am, am I audible to you?
Yes.
Yes, ma'am.
So I have started the streaming and I have given the link in the chat. So today we will continue with week 1. So what are the topics we have covered in the previous session? Did you all go through the topics we have seen already? Yeah.
Yes, ma'am.
So these
Yes,
are the
ma'am.
topics we have seen,
First,
right?
we
We saw
saw
Yes.
water vectors and then we saw some operations like vector addition and scalar multiplication. And we
Yes,
saw
ma'am.
how to visualize them in R2 and R3. And then we saw what are matrices, what is mean by rows of a matrix, what is mean by columns of a matrix, right? And what is mean by size of a matrix, right? So these are the things we have seen about a matrix.
Yes, ma'am.
Hold on, I'm just looking what happened to my system today. Hold on. Sorry, there is some issue with the usual PDF reader I'm using. So I'm switching to another PDF reader. So the screen is visible, right?
Yes, ma'am.
yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So suppose we are having a matrix. Let us say we have a matrix like this. Now, can you say how many rows are there and how many columns are there? What is the size of the matrix?
3 cross 2.
3 by
3 by
Ma'am,
2.
ma'am, two. Yes, ma'am.
2.
3 by 2. 3 by
Rows
2.
and 2 columns, right? Okay. So, and then we saw different types of matrices. Rectangular means you have an m by n matrix where you have m not equal to n, right? And then you have square matrix where you have m is equal to n. So the number of rows and the number of columns are same.
Yes, ma'am.
And then what are diagonal matrices? Diagonal matrices or matrices, square matrices. They are all square matrices. So diagonal, square, scalar, identity, triangular. All these are n by n matrices, right? These are only for square matrices. So they are square matrices where, what do you know about the diagonal non-diagonal entries of a diagonal matrix? So if you have a
0 0.
matrix A,
Ma'am, 0 0.
yeah,
Up,
Aij should be 0 whenever I
yes,
is
ma'am.
Not equal to 0.
Not equal
not
to
equal
J.
to j, right? So these are diagonal
Yes, ma'am.
matrices. And what are scalar matrices?
The diagonal entries are equal.
They are
Yes, ma'am.
diagonal matrices.
The diagonal entries are
And
equal.
yeah, so
Equal.
all aii are the same scalar, right? And here these are all any m by matrix where all the entries are 0, null matrices. It can be either rectangular or square, right? And what are identity matrices?
A scalar
It will
matrix
be
I
Diagonal
in
entries are
same.
1.
All diagonals are 1.
Yes,
So
ma'am.
of diagonals are 0 and other diagonal entries are all 1, right? And how can we write triangular matrices using this kind of a notation? Can you tell? So for example, maybe
Upside of triangular.
let us take maybe 2 cross 2 so that you can easily visualize A11, A12, A21 and A22. Okay. Now here this is your I and this is your J. What is the relationship between I and J?
I not equal to J.
Okay. I is
Not equal to.
less
Not
than
equal
J.
to.
Less
Yeah,
than
less
J.
than J.
Less than J.
I is less than J, right? For this, I is less than J. And then here you have I is greater than J, right? So it means
Yes.
what? Below diagonal, everything will have I greater than J, right? You see here A31, A32. So these are the entries below diagonal. And what are the entries above diagonal? A11, A12, A13. For all this, you can observe that I is less than J, right? So now using this property, can you first of all describe lower triangular?
Aij equal to
Yes,
0
ma'am.
where I is less than
Ma'am,
0.
I is less than J.
Yeah, Aij should be 0 whenever you have I is less than
Less
J.
than J.
This is lower. And for
Yes.
upper,
Ma'am, I is greater
I
than
is
J.
yeah, Aij is 0 for I greater than J, right? Okay.
Yes, ma'am.
And then you know how to do addition of matrices and scalar multiplication of matrices. We have already given a introduction to matrix multiplication. Today we will see some examples, and then we see two more matrix operations, transpose and determinant. Okay, and then we also have a outline of what is a system of linear equation. So these are the topics of week 1. So up to this we have already covered. So today we will be seeing the remaining topics of week 1. All right, shall we move to the new
Yes.
topics here?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So I have already given this explanation of how to
Yes, ma'am.
multiply this R and C, and you obtain this, right? Same way I have explained how we got A into B, and this expression also we have already seen. Now maybe let us see some quick examples. All right. So 1, 2, 3, -1, 0, 1. Now what is the size of the matrix?
3
3
cross
by
2.
2.
This is a
Ma'am,
3
3
cross
by
2
2.
matrix. Yeah. So this is a 3 by 2 matrix. Let us call it A. Now, if I have a matrix like this, what is the size of the matrix?
2 2.
2 cross 2.
2 by 2.
So is this matrix multiplication possible?
Yes,
Yes,
ma'am.
Yes, ma'am.
What will be the
Yes, ma'am.
size of, let us call the
Yes, ma'am.
matrix AB
3
A,
into
B,
2.
S, C. What is the size of this matrix?
3 cross 2.
3 cross 2, ma'am.
3 by 2.
3
3
cross
cross 2.
by 2.
Right? So let us do A into B. How to do A into B? What is the first entry of AB? So first row into the
One row.
first column. So what is the answer?
1. 1.
1.
And first row and second column.
1.
1.
1.
-1 plus 2 is again 1. And then second row and first column.
3.
3. Second row and second column.
-4.
-3 minus 1 is -4. And third row first column.
0.
And third row second column.
1.
1.
So this matrix multiplication is clear for everyone, right? Yes?
Yes, ma'am.
Okay. So let us maybe do a simple matrix multiplication. So maybe let us have maybe the same A matrix. Now I am going to change another matrix. So let us have this matrix as -3, 0, 0, -3. Okay. So now what is A into D?
-3 first element.
So the first entry
One.
here is
-3.
minus
Minus.
here
Yes, ma'am.
-0. 0 or
Minus
6? Who said?
-6.
0 or
Minus
6? Tell me the correct answer.
-6.
-6, right? So you have -3 times of
-3.
-6.
Yeah.
-6, ma'am.
2 times, so -6. Okay. And then here row 2 times of the first column,
-9.
-9.
and then
+3.
row 2 times of the second column,
3.
3, right? And then here 0, 1,
-0.
0.
0.
And then here this into
-3.
the third row into the second column. It is -3. So what do you observe? Can you write it as a scalar times of A?
Yes.
What is that
Yes.
scalar?
Minus
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 Three,
minus
ma'am.
3.
Minus,
3. Yeah.
right? So you
Ma'am,
see that this yeah.
ma'am, in AB matrix, the last element should be 0.
Sorry.
In AB matrix, the last element should be 0 instead of 1.
So row 3 into column 2. 0 into minus 1 is 0. 1 into 1 is 1. So you have 1, right?
Okay, ma'am, okay, sorry.
Okay, fine. Okay. Now tell me, can you write D as some scalar times of identity?
-3.
-3.
Again, minus 3. Okay. So what is that you notice? So when you multiply with scalar times of identity, that is you multiply with a scalar matrix, simply you are multiplying with the scalar, right? You can experiment with multiplying D maybe with some other size of the matrices. You can experiment what happens when you multiply any size of scalar matrix before or after to another matrix. This is what usually happens. Okay, fine. Now let us take a very simple case. So let us maybe take a different matrix. Let us call it maybe X. Okay, I'll take a simple matrix only. Now can you tell me what is X into B?
-2. First element.
Minus 2,
First
2.
2,
5.
5, and
5. Minus
minus
2.
5 plus 3 is minus
Minus
2.
2.
Same way, can you tell what is B times of X?
Minus 7.
Okay, minus 7, minus 2, minus 5. Yeah, minus 7, and then here
3.
-3.
minus 3.
-3. Yeah.
5.
5.
Yeah,
5.
5.
5.
3.
3.
3.
3.
So you can notice that XB times X into B is not same as BX. So you can see that matrix multiplication is not commutative. What is mean by commutative? What happened?
No,
My God,
reverse is
again
A
not.
this
into
PDF
B
also
equal to B
crashed.
into A.
My God, what's wrong today? Everything is crashing,
It came back.
but everything I wrote is gone. Hmm, if it keeps happening, then how to continue? Just please hold on. I don't know. Today there is some error problem with my system. That's why there are so many disturbances. Please hold on.
I mean, this Microsoft Edge, it won't save automatically. You have to go. You got to save every time you write a few words or something.
I guess you can upload it to OneNote and then use it. It will be better. It will save automatically also.
Please hold on. I'm just checking it. Sorry, the other one is not I really have managed some tool here. Let's see how it goes today. I'm really sorry.
Not an issue, ma'am. Whenever you come, actually we are our own place, right? So we don't have any issue. You can take your time. Just please fix the issue so that we can continue with the class.
Ma'am, in that time you can give some tasks to us, like solve some questions, so that we will be, discussing after. Ma'am.
So let us try with this online tool. I hope I will be able to manage with this tool for today's class. All right, let's see. So
Okay.
we were looking at the topic matrices. Okay. Fine. So the screen is visible, right?
Yes, ma'am.
Okay.
Yes, ma'am.
So in matrices, the point we saw was that, so for any two matrix A, B, okay, so in this A, B need not be, it may be possible for some matrices that A, B and B are equal, but A, B need not be, in general, they need not be equal to B, right? A, B need not be equal to B, A, right? So here you see that matrix multiplication is not commutative. Okay, matrix multiplication is not commutative. Okay, so the next thing we are going to see is what are symmetric matrices. So
Ma'am, what
did
is
we see what are
commutative, ma'am?
Okay, commutative property in the sense that, okay, let us consider real numbers. Okay, in the case of real numbers.
Excuse me, ma'am. Sorry
Yes.
to interrupt. Matrix multiplication is commutative in case an identity matrix is multiplied to that matrix.
See, what is mean by commutative property for a set? It means for any two elements in the set, the property should hold. That is what is mean by a property satisfying for a set. If it does not satisfy even for one single element of the set, then that property is not satisfied for the entire set. Okay?
For the
So
entire
that
set.
is what I said. That is why I am using the word need instead of saying will not be equal to. Okay, do you understand why I'm using need instead of will not be equal to?
Ma'am,
Okay.
means, ma'am.
Yes, do you understand the difference? Yeah.
Yes, ma'am. Ma'am, commutative should be, ma'am, BA equal to AB.
Yes, yes, that is commutative property. So what is commutative property? Since many of you have doubt with what is commutative property, I guess you may have forgot what is this property. It means that commutative property means AB is equal to BA. This is what is called as commutative property. All right. So for real numbers, are they commutative? If you take any two numbers, you can reverse it, right? So if you take two real numbers, alpha, beta, that is going to be same as beta into alpha. But it is obviously not true in the case of matrices. We saw with the example X and B, right? XB was not same as BX, right? In fact, what happens to their order? Sometimes their order may be different, right? Then you cannot even compare about the equality of matrices. Only when the matrices are of same size, then you can talk about equality, right? For example, let us say you have a 3x2 matrix and you have a 2x3 matrix. Now, what is the size of the matrix AB?
3 cross 3.
3 cross 3.
3 cross 3. And what is the size of the matrix BA?
2 cross
2 cross 2.
2 cross 2. So they are not even comparable. Only we can say compare two matrices when they are of same size. Here you see that they are not even of the same size. At least when they are of same size, you can still say that they did not be equal. Okay, first of all, you can see that in general order need not be equal. Suppose we are assuming both are of the same order. Both are square matrices, let us say. Even then, they need not be commutative. This is a general property for matrix. All right, is that clear?
Yes,
Ma'am,
ma'am.
need not in the sense that
Yes, for
can be
example,
exception, right?
yes, there are several exceptions. One very obvious example I can tell is that for the matrix, if you take identity matrix, it will commute with all kind of matrices. Sorry, not B, it's A. Identity matrix commutes with all matrices. Okay. So this is an example. So you can see some exceptions like this. Maybe scalar matrices also work. There are several other matrices which works here. Okay. So matrix multiplication is not commutative. Is that clear for everyone?
Okay, ma'am.
Yes,
So
ma'am.
basically, except this exception, otherwise it's not commutative.
Not only this exception. There are several exceptions I told. I'm just giving an example here.
Okay, sure.
Okay.
What about the order of the identity matrix, ma'am?
What about?
The order of the identity matrix here, ma'am.
Yes, of course, we are taking the same matrix, but even if you are taking a different order, then like suitable order, here I is the same matrix, right? So here if the order is different, then you cannot just simply interchange the sizes. Let us assume here A is an n by n matrix and I is also an n matrix, n by n matrix. All are the same size. Okay, then only here, in this case, it will make sense.
If the order
Okay?
will be same, then it will be commutable. Okay.
Yes. Okay, fine. So matrix operations, we are seeing that you have matrix addition, scalar multiplication, and then we saw what are matrix multiplication, right? So the next thing is that did we see what are symmetric matrices? Have we seen what are symmetric matrices?
No, ma'am.
No, ma'am.
Ma'am, symmetric
No, ma'am.
matrices guess transpose is equal to the real
Sorry?
matrix.
Sorry.
Transpose is equal to the real matrix. Matrix is
The
equal to
matrix
the
in which the
Okay, so
original
there
matrix
are some
is
properties of matrices you have and then transpose of a matrix. Okay, let's go in that order itself. So properties of matrix, you can simply check by giving some examples. There is nothing much I have to explain in property of matrices. So you just have to go through the properties, and if you have some doubts in the properties, maybe you just give some examples and check. But most of them are quite obvious. So you can see associativity properties. So addition is associative, multiplication is also associative. That means you can change the brackets. When you have three matrices and you are performing addition or multiplication, you can change the brackets, right? And commutativity of addition is possible. Only multiplication is not possible. The commutativity is not possible only for multiplication, but for addition, commutativity is possible. Okay. And yeah, the other property I have, as I already told you, commutativity is not true for multiplication. Then you have the various distributive properties. Okay, distribution over scalar and also with matrix multiplication is given there. Okay, so these are some matrix properties which you can easily understand with examples. So the next topic we are going to see is transpose of a matrix. So transpose of a matrix. What is mean by transpose? So for transpose of a matrix, let us consider a matrix M by N. Okay, A is a M by N matrix. Okay, so the transpose of this matrix is an N by M matrix. The notation is A transpose like this, and the order of this matrix is N by M. And how are the entries going to look like? If you have the entries Aij here, so here everything is simply going to be swapped. For A transpose, you are going to have Aji. Okay, maybe if you see some example, you will feel that this is very easy operation. Okay, so let us look at an example. So A is equal to 2, 3, 1, minus 1, 0, 3. Now what is the size of this matrix?
3 cross 2.
3 by 2.
Right? Now can you tell me what should be the size of A transpose?
2 cross 3.
Right? And here you see that the rows are going to become the columns and the columns are going to become the rows. Okay, so the 2, 3 is the first row. That will become your column. And the second row will become your second column. The third row will become your third column. So this is what is transpose. The rows and columns gets interchanged. What happens in transpose? Rows and columns
Get interchanged.
yes, right? So here you see that what is Aij? So maybe let us talk about A12. What is A12? 3, right?
A21.
And
A3.
here see that what is there in the position of, let us call this matrix maybe B. What is B21?
3.
Right? So you can see that Aij will be the Aji value here for this matrix. Okay? So Aij's will become Aji here. Okay? Fine. So do you all understand what is mean by transpose of a matrix?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So now we will see what are symmetric matrices. So for symmetric matrices, we need this definition of transpose. What are symmetric matrices? So for symmetric matrix, we are talking only for square matrices. You take an n by n matrix. You say that this is symmetric if A transpose is equal to A. Okay. This matrix A is symmetric if A transpose is equal to A. Okay. So for example, if you consider maybe, let us say this, maybe start with 2 by 2 matrix. A is equal to 2, -1, -1, 5. Now what is A transpose? Can you tell me? You have to write the rows as columns here.
2 minus 1 minus
Minus 1 minus 1, 5.
You see that A transpose is equal to A. Right? So now what is the other property you notice between these entries? Aij is equal to
AKI.
Ai. Right? So
Yes, ma'am.
A12 is equal to A21 in this scenario. In this scenario, you see that A12 and A21 are same. So let us see another example for 3 cross 3 matrix. So A is equal to, I will write only one half. Let me see how many of you are able to manage the other half. Can you tell me what are the 3 entries here? What should be this entry? 3. What
3 minus 1 and 2.
-1, 2.
Yeah, so if A has to be symmetric, then if you know the upper triangular part, then you know the what is the lower triangular part as well, or vice versa. So you all understand what are symmetric matrices?
Yes,
Clear?
ma'am.
Okay,
Yes, ma'am.
fine. Okay, fine. So the next topic is skew-symmetric, I guess. So skew-symmetric matrices.
Ma'am?
So, yes?
So this symmetric matrix is an exception of this transpose or what, because it is not following that property of Aij is not equal to A is equal to Aji.
Sorry, what?
This symmetric matrix, I mean, here Aij is equal to Aji, which is not in general, right, for transpose.
See, this is a specific type of matrix, just like diagonal matrix, scalar matrix. So this is a specific type of matrix. A matrix is called symmetric if this property holds. All matrices are not symmetric, right? You have plenty of examples to say all matrices are not symmetric, right?
Yeah. Okay.
Yeah. Okay. So what are skew-symmetric matrices? So skew-symmetric matrices are again square matrices. You can talk about skew-symmetric property only for square matrices if you have A transpose is equal equal to minus A. Okay, your transpose should be equal to minus A. Okay, so now for A transpose is equal to minus A, what kind of condition will you have? Just like you have Aij equal to Aji here, what will be the condition here?
When AI is equal to
Ma'am,
minus
AI
one
equal to
minus
minus Ji.
Okay, so now if I is equal to J, what will happen? Can you just think a moment and tell me? Don't answer quickly. If I is equal to J, what is going to happen for Ai?
G, it becomes 0.
Yes. See, if I is equal to J, then you have Aii is equal to minus
Minus
Aii.
JJ.
So this means that you have 2Aii is equal to 0. This means that Aii is equal to 0. Agreed? Yes or no?
Yes, ma'am.
Yes,
So
ma'am.
for a skew-symmetric
Yes, ma'am.
matrix, what is the other important property you see? All
Diagonal
diagonal
matrix should be 0.
entries are 0. Okay, all diagonal entries are 0. So, of course, this is the definition. From this definition, we have arrived that all diagonal entries are 0. So, now let us look at some examples. So, first of all, let us take a 2 by 2 matrix. What should be the diagonal entries if it is skew-symmetric?
Ma'am, 0, 0.
Yes. Okay. Now, let me write this as minus 2. What should be this entry? Can you tell?
Plus 2.
Ma'am, 2.
Yes.
Only 2.
Yes, only 2 because Aij is minus Aj now. Okay, so you can see that A transpose is equal to minus A for this case. Correct or not? Yeah?
Yes, ma'am.
True. Right? Okay, now let us see maybe a 3 by 3 case. So A is equal to, the diagonal entries are 0. So let me write this part. Tell me this part.
Ma'am, minus 1,
minus 1, 3 and
3
2.
and minus 2.
3 minus 2.
Minus 2.
Okay, so for this
Yes,
is
sir.
also a skew-symmetric matrix. Okay, fine. Okay. So the next, I guess, exercises are there. Okay, let us see the, maybe we look at, okay, it's okay. Let's see one by one itself. So exercise 1.
Ma'am, I have some doubt, ma'am.
Yes.
Actually, I tried to do the multiplication of matrices, but I couldn't do it.
Okay.
So, if you get time, ma'am,
Did you
can you
try it
explain one more
again?
time? Yes,
Okay.
ma'am. I just now, when you were not there, I was trying to do it myself, but I couldn't do it.
See, we are already going a little late. So can we come back to it maybe in the TA session? Because now if I am going back there, we will be lagging behind too much. Okay.
Okay,
So
ma'am.
shall
Ma'am,
we
at
go
last,
look at it?
at last, if possible,
Yeah.
ma'am.
Okay, if possible at last. Otherwise, you can ask in the TA session. The TAs are going to explain everything. Whatever I'm going to explain. Whatever I'm explaining here, everything with examples they are going to do. So if we don't have time, please look in the TA session. All right. Fine.
Okay, ma'am.
So let us look at the exercise now. So exercise 1. So in the exercise 1, any diagonal matrix is a scalar matrix. True or not?
Yes, ma'am, true.
Any diagonal is true. So for example, let me take 1,
No, ma'am.
2, 3. So this is a diagonal matrix. But is this
No, ma'am.
scalar?
No, ma'am. No.
No, ma'am.
No,
So
ma'am,
this
no.
is diagonal but not scalar. Correct?
Yes, ma'am.
Yes, ma'am.
Okay. What about the second option? So option 1 is this. Option 2 is scalar matrices may not be square matrices.
False.
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 Square.
Because scalar matrices are always square.
Always.
Yes,
Right?
ma'am.
So
Yeah.
the next option is scalar matrices must be square matrices. Of course, true. right?
Yes.
And option 4, any scalar matrix is an identity matrix.
No, ma'am.
No,
No,
false.
right? So this is scalar, but is this identity?
It can be product of identity matrix.
But the
Not
question
an
is, it is
Scalar multiplied by identity.
scalar but not identity. Okay, this question is saying that the option is saying that any scalar matrix is identity, but it is not identity. Okay, fine. Okay, so then the second question. So you have the matrix P. Can you say what is the size of the matrix P? It is, suppose, let us say you are having a 3x3 matrix, and Q is a 1x3 matrix.
Ma'am, question is not visible to us.
Okay, that's why I'm just writing the size of the matrix. P is a 3x3 matrix. Q is a 1x3 matrix. I'm just, if you have the PDF of the previous session, you can keep it on the side. Otherwise, no issues. I'm going to write this question in short. So R is a, again, 1/3 matrix, and you have D is a 3x1 matrix. So these are the different sizes of the matrix you have. Now you have to tell whether the following orders of the matrix. So what is the order of the matrix P D?
3 cross 1.
3 cross 1.
3 cross 1.
So what is the order of the matrix QD?
1
cross
cross
1.
1.
1 cross 1.
1 cross 1. So it means it just have one single number, right? Okay. What is
1 1.
the order of DQ?
3 by 3.
3
3
by
cross
3.
3.
3 cross 3.
What about the order of QD?
1 cross 1.
1 cross 1.
1 cross 1.
Okay.
1 cross 1.
We have already. Okay. What about QR?
Not possible.
Not
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 possible.
possible.
Not
fine, yeah.
defined, right? So QR is not defined.
Yes.
What about P plus Q? Is it defined?
No, ma'am.
No, ma'am. No.
No,
This is
madam.
also not defined, right?
Ma'am, can you tell me the reason of P plus Q is not defined?
Are they of the same size?
Okay. No, ma'am. Yeah.
Okay. For addition, that is the main condition, right? What about P plus D?
Not
Not
defined.
Not defined, ma'am.
That
No,
is
ma'am.
also
No,
not
ma'am.
defined, right? Okay. So
Hi, ma'am. I have a little
this is
doubt, ma'am,
just one.
here.
Yeah.
Yeah, okay.
Tell me.
Can I ask, ma'am?
Yes.
Yeah. So, ma'am, in the previous case, like where AB is equal to BA, ma'am. So,
Mm-hmm.
is there any certain conditions that we can identify in the pattern? Like, if you say that these two metrics will be like follow these certain conditions, then we can surely say that AB is equal to BA. Otherwise, it will be AB is equal to not BA.
So you want to under which condition AB is equal to BA? I
Yes,
guess
ma'am.
that condition is not very simple, and I have not specifically looked for that condition. Maybe you can come up with a solution for 2 by 2 if it is possible. First, try for 2 by 2, because even
Okay.
for 2 by 2, it is not that simple, I guess. Okay, just try for 2 by 2.
What
Okay.
was the question?
The question is that he is asking, is there any specific conditions on A and B which will guarantee that AB is equal to BA?
Okay.
Okay. So maybe you just try for 2 by 2. Even for 2 by 2, you will see that the expression is not going to be very simple. Okay.
Okay. So, ma'am, this is only regress way that AB we have to
So
multiply
some
these.
very obvious cases are, you can see maybe the scalar multiplication, identity matrix. Okay, so these examples you can see, but yeah, you have to experiment and check for other cases. Maybe
Oh,
I
okay,
will
ma'am.
also look any specific conditions are available. Maybe it is available, but I have not specifically looked for it. Okay, fine.
It
Ma'am,
might be
actually, I
combination of
searched it
identity
on.
matrix.
ChatGPT, ma'am, they show some like concept regarding eigenvalues and vectors, something like that. So actually, this concept here arises, so that's why I ask you.
See, this course does not include eigenvalues and eigenvectors. We are not doing that in this course. No.
Okay, okay, ma'am. Yeah, sure,
Okay,
sure.
let us continue with the exercise now. So the question now is, let us say you are having a matrix A, which is 1, 0, 0, minus 1. And you have another matrix B, which is 0, 1, 0, 0. Can you tell everyone now try this matrix? Those who said matrix multiplication, you don't understand, now it's one opportunity. Try the simple example. What is A square? So 1, 0, 0, minus 1. So now find what is A square. So what is that you need to do? First row multiplied to the first column. 1 into 1 is 1 and then 0 into 0 is 0. So 1 plus 0, 1. Then first row with the second column, 1 into 0 is 0. 0 into minus 1 is again 0. So 0, 0, 0. Here 0 into 1 and then minus 1 into 0. Both are 0. So again 0 plus 0, 0. And here 0 into 0 is 0. Minus 1 into minus 1 plus 1. So 0 plus 1 is 1. So what is this matrix?
Ma'am, identity.
Yeah.
Identity matrix.
It's an identity matrix. And what is B square? Now this is an exercise for you. Try it and tell me what is B square.
Ma'am, first of all will be
It will be 0, 0, 0
Yes.
and 0, ma'am.
Zero matrix.
All entries are 0, right?
Null
Yes,
matrix.
Yeah.
No, yeah, this is a null matrix. But what about B?
It's a
What
matrix.
about B? It is not a null matrix. So this is something special about matrices. Okay. So in a real number scenario, what is that we see in real numbers? So if alpha into beta is equal to
Ma'am,
0,
is
you
B
see
is triangular matrix?
Sorry?
Upper triangle.
Ma'am, is B is upper triangular matrix?
Yes, you can say it is upper triangular. Yes. Okay. Fine. So what is that I wanted to say is that in the case of real numbers, alpha into beta, if it is 0, you know that alpha is 0 or beta is equal to 0. But in the case of matrices, that is not the case. The product of two matrices can be 0 if those matrices are not 0. Okay, that is possible. Okay, the product of two matrices can result in a 0 matrix even if the original matrices are not null matrices. Okay, clear? Fine?
Yes, ma'am.
Okay.
Ma'am, can you repeat again?
See, what we did, we have non-zero matrix. This is a non-null matrix. But when we multiply this twice, then you see we are obtaining a null matrix. So in the real numbers, it is not the case, right? For real numbers, what happens? For real numbers, if you take two numbers alpha into beta, suppose alpha and beta are real numbers. And if you have alpha beta equal to 0, what will you usually write?
Either alpha or
Whether
beta
alpha
is
is equals to
zero.
0 or beta is
Yeah.
equals to 0.
But in matrix, it is not the case. AB is equal to 0 does not imply A is equal to 0 or B is equal to 0.
Yes, ma'am.
Okay, this is what I wanted to
Yes,
say.
ma'am.
All right. So, the
But
next,
ma'am, here we multiplied with the same matrix, ma'am, right?
see, that
We
is
just multiplied
in
B
this.
with B.
This is one example where we are A and B are same, but I'm saying in general this is also true. Okay, that you may
Okay,
have
ma'am. Okay,
two
okay.
different matrices. Both are not null, but in resulting matrix is null.
Okay, okay.
Okay,
Got it. Yeah.
fine. Okay, let us say you have 3 by 3 matrix. I'm going to give you a small exercise here. You have a 3 by 3 scalar matrix. Everyone, please listen carefully. This is an exercise for you. A
Yes,
is a
ma'am.
3 by 3 scalar matrix. A11 is equal to 4.
Okay.
And suppose you are having another matrix 3 by 3 matrix B. Okay, And the entries are given in this way. Dij, the entries are I square. Okay. Now find 2a plus b, and specifically 2a plus b, the and two entry. Okay.
Okay, ma'am.
So this is an exercise for you. I'm going to give another exercise also.
I guess a similar question is activity.
So what is that 2a plus b?
That's all. It's nothing here. Just I wanted to put a comma.
Okay, okay.
Ma'am, do we need to find here the matrix A and B?
Yes, yes. Find it.
Ma'am, can you give some, like, how to solve these things?
See, first write what is your matrix B. A you cannot find entirely. Okay, but yes, A you can find entirely because it is given a scalar matrix. Just use all the information given here. You will be first able to write what is A and what is B. Then do this. Okay. So do these exercises. We will continue again in 5 minutes. Okay, I will be back in 5
Okay, ma'am.
minutes. Try to complete this.
Can you please mute? Actually, it's causing a lot of.
Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
I am not ma'am, I am student. I am asking.
Raj, you're audible.
Yeah, you are audible.
I am just asking कि मुझे ये आवाज नहीं आ रही है, किसी को भी नहीं आ रही.
I'm done with the
Ma'am is
question.
on a short break. He asked us to do these two
Ma'am, done with
questions.
the question. Yeah.
Yeah, please mute yourself.
Hey guys, did anyone get the value of A?
Yes. 10,
Yeah,
5,
it's
10, 5,
scalar
15,
matrix.
13, 10, 13, 26.
Sorry, how did you get that?
Yeah, we have got it. Just square it, then add I with it, then you will get some scalar
Like
of A.
All the diagonals of 4 rest are 0.
oh sorry, मैंने B का बता दिया भैया.
Did everyone get how to pose the question?
Guys, how can you get the value of A? I think the data is insufficient
A
in
is
question
already
4.
given in the question, right?
So it is a scalar matrix. So you can, and it is given that A11 is 4, so all the diagonal elements will be same with equal to 4. Another element will be 0.
2A plus B came as 16. Anyone else with the same?
Okay, so I hope most of you were able to manage. How many of you were able
Yes,
to
ma'am.
manage?
Yes, ma'am.
Yes,
Yes,
ma'am. We're
ma'am.
done.
Okay,
Done.
fine. So, given A is a scalar matrix. So, what do you know about scalar matrix? Off diagonal entries are
0.
Zero.
Equal.
Same.
right, and it is given the first diagonal entry is 4. So, what should be the other diagonal entry?
4, 4.
Four.
4, right?
Yes, ma'am.
Okay, now what about the matrix B?
First element is
So we
2.
1, 5, 10.
First
2, 5,
2,
1
5, 10.
10.
1 means you have 2,
5,
2,
10, sorry.
and then 1 2 means
5,
5,
5, 1 10
10.
10,
means
10.
10. Okay, and
5,
then what about the
5, 8,
5,
diagonal?
13.
5, 8, 13.
8,
And 13, 18.
13.
Then
10,
10,
13,
13, and 18.
18.
8.
okay, so now you know what is A and B, so you can easily find what is A plus B, right? So A
Yeah.
plus B is, what is A plus B? 6 5 10
6.
2A plus B, ma'am.
5 12
And
13.
Ma'am, 2A
2A
plus
plus
B
B.
now.
2A plus B.
Oh, fine, fine, fine. So 2A plus B. So the first entry here is now 8. 8 plus 2 is 10.
10,
And again 8 plus 8
5.
is
5, 16.
16.
plus 8, right?
And at the
And
last
then
18.
10,
10,
13
13,
and
and
26.
here
26.
8,
26.
26. So what is the 2AB 2 to entry?
16.
16, ma'am.
Okay, good. Fine. So now, what about the next one?
6.
6.
Value of
6.
alpha is
2. Value of alpha is 7 and 1 minus 1 by 7.
6.
Okay, let us see. What is a square? Can you quickly tell me the a squared values?
Minus 7.
Minus 7.
Minus 7.
minus 7, 12, minus
12.
24, and 41.
41.
Minus 7, 12,
12 minus
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 24.
24,
24 and
41.
41.
Okay, okay.
41.
Now, when you do a square minus alpha a plus I, what is the matrix you get?
We are getting
Minus 6 plus alpha.
So, minus 7 plus alpha,
Plus
not alpha, minus alpha, right? Or, oh, minus into
plus
minus plus only. Okay.
yeah,
Plus
plus 1.
alpha plus 1. Right? And what is the next entry here? So you get other entries. The other entries are not required because if this is there, you can easily compute with
1
this
is enough.
itself.
Yeah, 1
Yeah,
is enough.
yeah. So minus 7 plus alpha plus 1, you know that this is equal to 0. So what should be alpha then?
6.
6.
6.
minus 1.
Right? Alpha should be 6. Okay, is that fine for everyone?
Yes, ma'am.
Yeah.
Okay.
Yes, ma'am.
Okay. So now again we are going to look at another topic which is trace of a matrix. This is very simple. So the trace of a matrix is nothing but the sum of the diagonal entries. So you have a n by n matrix. So trace of A, it's nothing but sum of diagonal entries of A. Okay. So I will give you a matrix. You tell me what is the trace of the matrix. So let us say you have matrix. What is trace of A? Can you tell me?
2.
2.
2.
Right? Minus 1 plus 3 is 2. Right? Now, can you tell me what is the trace of identity matrix?
2.
Just
The order.
order is
Order.
let us say
Order.
D by D. I3. What is the trace of
And
I?
3.
3.
In general, trace of IN is
N.
And
N.
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 right. Okay, so you understand what is trace of a matrix, right? All right.
Yes, ma'am.
Okay, so now we are moving to another topic, which is system of linear equation. See, the order will be the flow. I'm just following the flow of whatever the lecture contents are already there provided for you. That's why I'm now going to introduce system of linear equation, and then I'm going to introduce determinants. Okay, I'm just
Okay, ma'am.
following the flow. So now the next topic is system of linear equation. So what are system of linear equations? For that, first of all, you should know what are linear equations. Okay, so what are linear equations? Can you tell? So any equation of the form, let us say a1x1 plus a2x2. Okay, so you may have any n number of variables. Okay, but the powers of these variables are just 1. All of these variables are having power 1. Okay, such an equation is called a linear equation. So this is called a linear equation. How many variables are here?
N variable.
So this x1, x2, xn, these are the variables. Okay, so these are the variables, and all the other a1, a2, an and b, they are constants. Okay, fine. So here you see that we are now going to talk about system of linear equation. It means you are going to have more than one equation. Okay, so for example, now I will consider a problem here. Okay, so the problem statement I will write. So you are going to look at this problem statement and you are going to frame some linear equations from this. Okay. So the cost of a ticket is equal to rupees 25 for children. Okay. And it is rupees 50 for adults. Okay. Now on one day, okay, so the total count of tickets, okay, attendance in the sense total count of tickets. Total count of tickets sales per day is 2000. On one particular day we are talking. Okay. And the total revenue is rupees 70,000. Okay. So now the question is, how many children and how many adults bought tickets? So everyone read the question again, take a moment before answering, and then step by step we will see how to frame linear equations from this.
It is rupees 25, right, ma'am?
Yes, this is rupees 25. Everyone just go through carefully. Take a moment.
Ma'am, suppose number of children is X and number of adult is Y.
Maybe
So
let's
first,
just 1 moment for the others also.
okay,
Just 1 moment,
okay,
let's wait. Okay.
okay.
Okay. So someone was saying.
A is 800 and B is 1200.
Okay. So what you said was that you said that let
Ma'am,
Adult is
X will be the number of children
okay.
and Y will be the number of adults.
Okay.
And so from first equation, we can say X plus Y is equal to 2000.
Very good.
And then from second, we can say 25X plus 50, Y is equal to 70,000.
Very good. Okay. So do you see how linear equations automatically arise when you look at even some simple problem like this? Okay. So linear equations are not something abstract. They are very much seen in almost many day-to-day problems. Okay. So linear equations are very important. And why are we suddenly looking at linear equations? What was the topic previous to system of linear equations?
Matrices.
Matrices.
Okay. Matrices are very much related to system of linear equation. In fact, for solving system of
Representation.
linear equation, yes, we are going to represent this system of linear equation as matrices. That's why we first saw what are matrices, because the purpose of matrices itself is that these matrices we are going to use it to solve system of linear equations. Okay. Fine.
Besides this system of linear equation, do matrices serve other purposes also?
See, mainly we are looking at solving system of linear equations here. Yes, there are some other situations when you are talking about data. So there are some other matrix properties or matrix operations where which is going to useful to understand the data. Okay, for example, you may have this kind of diagonalization, but in most scenarios they are going to represent some system of equations only.
Okay,
Okay.
thank you.
Fine. So here I gave this example so that you have a feeling that linear equations are not something just with variables and numbers. So they arise in natural scenarios. That's why I gave this example here. Okay. So now I will just write the general form for a system of linear equation.
So you're planning on training the ticket in July, right? And you have for teaching it? Yeah, yeah.
Are you asking a question here or
Let's break
there
ticket,
is
but not
some
share
disturbance here?
to this person at this point. So let's start already once he is like done with his production issue.
Over this, please
So
stop.
we can just tell him, like, hey, this is the topic, can you please work on that, and then we can proceed.
I muted him. System of linear equation. So what is the general form for system of linear equation? See here I have given a general form for a linear equation. Just like that, I'm going to give the general form for system of linear equations. Okay. So a11 x1 plus a12 x2 plus etc. a1n xn is equal to b1. a21 x1 plus a22 x2 plus etc. a2n xn is equal to b2. Now you have an1 x1 plus an2 x2 plus ann xn. So how many equations do you see here? Here maybe a m1, m2, mn, and here bm. How many equations you see here?
Oh, M.
N.
M equations. And how many variables you see here?
N.
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 Okay, you see m equations and n variables. All right. Okay. So now from this, we are going to write what is the matrix representation for this system of linear equation. How are we going to represent this as a matrix? So let us write these entries, the coefficients of the variables as a matrix. A11, A12, A1n, A21, A22, A2n, and so on. AN1, AN2, ANN. Multiplied with x1, x2, xn. This is equal to, sorry, here again I'm making the same mistake, AM1, AM2, AMN. Okay, but variables you have only x1, x2, xn. Okay, now you have b1, b2, bm. If you do matrix multiplication, are you getting back the first equation? Just check everyone. If you multiply the first row with this column vector, what is that you get? A11 x1 plus A12 x2
A1 to X2, A1
A1
and
right? So you see that when you multiply these two matrices, you get back these equations here. Okay, so you call this matrix as A. This is the vector X,
X,
and
and this
this
is
is the
B.
constant vector B. So this you call it as the unknown vector, and this is the constant vector. Okay, and this is usually the coefficient matrix. Okay, so we have represented this system as AX is equal to B. So the system of linear equation now has become this matrix equation AX is equal to B. Okay,
And
now
what
I
is
will
B
just
matrix called?
sorry, this is just a
B
constant vector.
matrix.
This is a constant vector. The values of B are given to you, the values of A are given to you, and you are asked to find what is X, the unknown vector. Okay, fine. So I will just give you few examples here. You tell me what is A, X, and B. Okay, so let us say you have 2x minus y is equal to 6, x plus y is equal to 4. Can you tell me what is your A?
2 minus 1,
2
1.
minus 1, 1, 1.
So here let us maybe, usually this bar is not given. See, this x and this x are different. Here this is representing the entire vector, and here your unknown vector is just this x and y.
So,
So
ma'am,
don't
rename
confuse
it
this
in
and
equation.
sorry?
rename it in equation x1, x2 maybe.
Okay, you want to write it in terms of that? Okay, fine. Let's do that. X1, X2. This is X1.
X1, X2.
Okay. So now you have this as X1,
X1, X2.
X2. What is your B?
6
4.
and 4.
6 4.
10.
Okay, so you understand how to represent a given system as matrix representation. You all understand?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Quickly tell me the next one as well. So let us say you have 5x plus z is equal to 6, 2x minus y plus 3z equal to 0, x plus y plus z is equal to 1. Now can you tell me what is your A?
5
5,
0
0,
501.
1.
1,
2
2
minus 1
2
minus 1,
minus
3.
1,
1,
3.
3, 1, 1,
1
1.
1
1,
1.
1, 1.
1 1 1.
So your unknown vector, even if you have x, y, z instead of x1, x2, you should know what is your unknown vector.
Yes,
Your
X, Y,
unknown
Z.
vector
X, Y,
is x, y, z. What is your B?
601.
6,
6
0,
0
1.
1.
0.
Note that if you don't have one of the variable, then we know that the coefficient is 0. That's why we put 0 here, because the y value is missing. It means the coefficient of y is 0. Okay?
Yes,
Fine.
ma'am.
Okay. So now we will see what are the possible scenarios when we look at the solutions of a system of linear equation. Now, what is mean by solution of a linear equation? First, let us see what is mean by solution of a linear equation. I will start with very simple case. Solution of a system of linear equation. So first, I will consider only one linear equation. Okay, I'm going to consider one linear equation. So maybe I'm going to consider only one variable. So 2x is equal to 6. Is this a linear equation?
Yes,
Yes,
it
ma'am.
is, ma'am.
Yes, ma'am.
So now for this, what is the solution?
X is equals
3.
to 3.
X
So
equals to 3.
you know that a solution is a value. So when you substitute it in place of variable, it should satisfy the equation, right?
Yes, ma'am.
Yes, ma'am.
Suppose you are going to have two equations. So for example, so this is one example. So I'm going to consider another example. So let us say you have x plus y is equal to 1. Okay. And let us say you have 2x plus 3y is equal to maybe, I don't know, 0. Now, what is the solution for this? How do you find a solution for this?
You, you
Y is
multiply
equal
the.
to
Ma'am, we can
X is
multiply
equal to
with
3
the
by 2.
equation with
X is
and
equals
when
to
Then
3
the
and y is equals to
solution is
minus
that
2.
yes,
2,
you
3, 1,
multiply
y
the
equals
first
minus 1.
equation with 2,
yeah,
and then you try to cancel
2x
out the
plus 3y.
common term in these two equations,
yes, ma'am.
Yes,
right?
ma'am.
So plus or minus here, and then here you see minus y is equal to
2.
2. So y is
2
equal to
minus
minus
2.
2. Okay. And what about the value of x then?
3.
3.
Okay. So now what is x plus y? 3 minus
1.
2, 1. So it is satisfying this equation.
Yes,
Yes.
ma'am.
Now
Yes,
what
ma'am.
about 2x plus 3y? So 2 times of 3 plus 3 times of minus 2. What is this?
0.
0.
0. Okay. So now what is mean by a solution now? So it means solution is now a set of values, or if you consider it as a vector. Okay. X is equal to 3, y is equal to minus 2. So now it satisfies this equation Ax is equal to B. It means when you put x is equal to 3 comma minus 2, then this equation is solved. Here x is this. Okay. So when I'm putting x here, you should understand from the context what it means. Okay. Don't get confused. So what is mean by solution of a system of linear equation? You understand that values should satisfy all the equations in the given system. That is called a solution for a system of linear equation. Now the question is, will the system always have a solution? What do you think?
Not
No.
No,
necessarily.
ma'am.
No, madam.
Okay. So there are
No.
going to be three possible scenarios when you are going to look at the solution of a system. Okay. So what are the three possible scenarios? Let us see. Okay. So possible cases for solution of a system of linear equation. So the first case is, so first of all, maybe I'll split it into only two cases. So when you have consistent and non-consistent. What does this mean? Solution exists.
And solution does not exist.
Yes. So the solution may or may not exist. And now, even if the solution exists, will it be unique? The question is, will it be unique? So now you consider consistent system. Again, it will have two scenarios. So either you will have a unique solution or you may have infinitely many solutions. Okay. So maybe just like that, if you see this, you may not understand. But if you look at some examples, you will clearly understand. Okay. So let us look at some specific examples to understand what does it mean by all these different scenarios. So totally how many scenarios you have? So you
Three.
Three.
can have either unique solution
Hmm.
or infinitely many solution or no solution. Okay. So these are the three scenarios. Okay. Fine. So maybe shall we look at the case when you have a unique solution first, because I put the number 1 there. Okay. So let us look at the example for this. Okay. Suppose a person A paid rupees 215 and B paid rupees 260. Okay, for some product. Okay, they are paying some amount. Okay, we want to find the price of each items using this data. Okay, so both are buying um, same amount of okay, hold on, I am missing some question or what. A and B are making some purchases. Okay, so now we want to find the price of each items. What are the price? What are the items? Rice and dal. Okay, so they both are buying rice and dal. Okay, so rice, you call it, you say the price of rice as rupees X per kg. And for dal, you say rupees Y per kg. Okay, now suppose I'm saying A buys, let us say the equation for A is given like this. Okay, so what does this mean? What
A
does this
buys to
mean?
But 2 kgs of
2 kg rice
rice
and
and
1
1
kg
kg
dal.
of dal.
Okay, now I'm saying the scenario, tell me the equation. Now B buys 3 kgs of rice and 1 kg of dal. What is the equation then?
3x plus
3
y equals to
3x
2.
y equals to
plus
260.
Now can you solve these two equations?
Yes,
Okay,
by
so you
subtract.
can solve. The
Oh,
solution is going to be, I will tell you the solution straight away. X is 45,
X equals to 45.
Y is 125. All right.
Yes.
So you see that in this case, how does the equation going to look like? So this equation is going to look something like this. So one of the equation is going to look like this, and the other equation is going to look something like this. So this is your common point 45 comma 125. So here drawing that here maybe is not very straightforward, but I guess you can visualize it for simpler equations. Okay, maybe I try to put it in Desmos, or here itself maybe you have some graphing calculators, I guess. I have never used it, so let's try. No, I don't want that. Let's try.
मैम GeoGebra यूज कर लीजिए.
Is GeoGebra or even simply Desmos is sufficient here? Okay,
Yeah,
maybe I'll
ma'am.
use Desmos here to just show you. So the first equation is 2x plus y is 215. Am I
215.
correct?
Yes,
Okay.
ma'am.
So the other equation is
3x
3x
plus y.
plus y is equal to 260, right?
Yes, ma'am.
Okay. So can you look at the tab now? This
Yes, ma'am.
page. So
Yes,
you
ma'am.
see
Yes.
that the
Yeah,
red
ma'am. We
line
are.
is nothing but 2x plus y is equal to 215 and the blue line is 3x plus y is equal to 260. And you can see that both of them are intersecting at which point? 45 comma 120.
125.
So you see that both the lines are intersecting exactly at one point. Okay, and that point is your unique solution. Okay, so when you are having a system of linear equation, okay, system of linear equation with two variables and two equations, then you are going to have something like this. You are going to have two lines. Okay, and those two lines in this scenario, you see that they are intersecting at only one point, which is given by this. And this is a unique solution for this system. So far, are you with me? You all follow? Yes?
Yes, ma'am.
Okay. So now let us look at the next scenario. So the next scenario is the infinitely many solution case. Okay. So the second scenario, what happened? Did I do something wrong? So here, the second one is the infinitely many solution case. So here you have buyer A, buyer B, and then rice in kg, dal in kg. So you have buyer A 2, 4 and 1, 2. So this is the data given to you. Now from this data, now again you are saying that A paid rupees 215 and B paid rupees 430. Can you tell me what are the equations you will obtain from this?
Yes, ma'am. 2x plus 4y
Plus
equals to
y.
215
2x
plus
plus
4y
4y is equal
equals
to
to
215, assuming that x represents the price
yeah.
of
Y
1 kg
represents the
rice
price.
and y represents the price of 1 kg dal.
Yeah.
Right? What is the next equation?
X plus 2y equals to 430.
Ma'am,
Hold on,
actually,
when
this
you write the
equation
equation,
is,
Sorry,
ma'am, ma'am, I assume it is
Ma'am, the
wrong.
equation is
It is
wrong.
right wrong.
2x plus y equals to
2x
2x
plus,
plus y
2x
is
plus
equal to
y is
2.
equals to 215
thank you, yes,
and
4x
4x
plus
plus
2y
2y
4x plus 2y is
equals to
equal to
430.
430.
correct, yes. Okay, so now these are the equations. Now what do you observe from these equations?
Ma'am, the equation two second
There
is
are
the twice of
infinite
equation 1.
solutions.
2x of
So
first equation.
this is nothing but, this second equation is nothing but 2 times of 2x plus y, which is 250. Right? You can see that
Yes, ma'am.
both the equation
Overlap.
represent the same line. Agreed?
Yes, ma'am.
Yes, ma'am.
Right? So if both the equations represent the same line, these two lines, at how many points do they intersect?
Infinitely many points.
At
All
infinite.
points on this line 2x plus y equal to 215 are going to be the solutions of this equation, yes or no?
Yes.
Right? So in
Yes,
this
ma'am.
scenario, obviously you see that here all points on the line 2x plus y equal to 215 are,
Excuse me, ma'am.
yes.
Ma'am, how can they say that the equations are wrong?
Okay, fine. See, here we are saying buyer A pays 215. So I wrote the buyer A's rice quantity and buyer B's rice quantity is equal to 215. But this 215 is paid by buyer A for buying rice and dal. How many kgs of rice? 2 kgs of rice and 1 kg of dal. You understand how we form this equation?
Yes, ma'am. Yes, ma'am.
Oh, okay. So here both the equations represent the same line. So all points on the line are solutions of the system. So we have infinitely many solutions. Okay, you all follow now?
Yes,
Yes?
ma'am.
Okay. So what is the
Yes,
last
ma'am.
scenario? Can you tell me? What is the last scenario?
No
No
solution.
solutions.
So now let us see now. You have buyer A is going to buy 2 kgs of rice and buyer B is going to buy 4 kgs of rice. And buyer A buys 1 kg dal and 2 kg, buyer B buys 2 kg dal. Now tell me what are the equations? Assuming
2x
A,
plus y.
hold,
2x
hold
plus
on, let me
y.
tell how much A and B are paying. A pays 215 and B paid rupees 400. Now tell me the equations.
2x plus
2x
y is
2x
X
equals
plus
plus
to
Y is equal
250
250.
4x
4x
plus 2y is
plus
equal to
2y
400.
and
equals
4x
400.
plus y is 2y is
4x
equals to
plus 2y
400.
equals to 400.
Now, can you form any relation like you formed in the previous scenario?
No, ma'am.
No, ma'am.
No.
No, right? So now let us look at the graph here. So you have 2x plus y is equal to 215 and 4x plus y, 4x plus 2y, right?
2y. Yes, ma'am.
Both are
Equal
parallel.
to
Equals to 400.
400. So what do you see then?
It
What do
is
you
going
see?
parallelly.
Parallel to each other.
They are parallel lines. They don't touch at all.
And they doesn't intersect at each other any point.
Yes, yes. So you see that they are parallel lines. They are parallel lines and never intersect. So if they don't intersect, that means they don't have a common point. So no solution, right? So no solution for the system. Do you agree?
So what we
Yes.
can say in the language of that question that no kg of rice and dal has been bought.
Can you please ask your question again? I don't understand your question.
I'm asking like if no solutions exist, then what we can say in the language of this problem.
Okay, you want to say non-consistent. Is that you are asking about this word?
Yeah, no.
Hmm.
In that statement, um,
About this
like the
problem.
problem.
About this
Yeah.
problem.
Yes.
So
Contradictory statement, I think. Like,
you can say that, or maybe the scenario is that the information is wrong. It is possible that the information is wrong, or it is possible that there was some offers or something going on when one buyer was buying and the other buyer did not have that specific offer. That is possible, or the data is incorrect. Something like that must have happened. All right.
These parallel line happen when the information is contradictory. One is saying something else, something, another is saying
Exactly,
something else.
exactly. Just since that student asked what would have happened in that scenario, I'm just telling about this specific scenario. That's all. All right. Okay, fine, fine. Okay, so far what did we see about system of linear equation? We first saw what is system of linear equation, and we saw how to represent it in terms of matrices, and then we saw when solving a system of linear equation, it may or may not have solution. So we have three different scenarios. One is a unique solution, one is infinitely many, the other is no solution. So we saw examples for each case, and we also saw geometrically how we can see that which scenario is going to happen for that given specific system. Okay, fine. So here you have some homeworks. Everyone please note down the homeworks. So try to plot and identify under which category it will fall. Whether they will have unique solution, infinitely many, or no solution. Try to plot or try to solve. It is up to you. Whatever method you use, you should be able to tell in which category it will fall. Okay, this is just for your understanding only.
Ma'am, can we use Desmos for this?
See, the final purpose is for you to understand. First, try to solve and then maybe use Desmos. If you straight away jump to Desmos, then the learning for you is going to be missing. Okay, you will get the answer, but you will not learn. Try to solve first, try to understand what's going on. Then finally, just to visualize or verify your answer, you can use Desmos. Okay, this is my
Ma'am,
suggestion.
is there any shortcut methods to find these things?
Yes, see, here we have just introduced what are the various possibilities for the solution. In week 2, week 3, week 4, I guess in week 2 specifically maybe, and also in week 4, we are going to see some techniques to solve system of linear equation. Okay, there are several techniques to solve system of linear equation. We will see it in the later weeks, not here. All right?
Excuse me, ma'am.
Yes.
Yes, ma'am. Can we get slides at the end of the session?
Yes, this should not be a question again and again. For all the sessions, the same procedure. You will get the slides right after the session. It will be there in the drive. Okay. Fine.
Okay, ma'am. Thank you, ma'am.
Okay. So we should now move to the next topic, which is determinants of a matrix. Since we started late, is it okay if I continue? Just at least give the introduction of what is determinants.
Sure, ma'am.
Yes,
Ma'am,
ma'am.
just can you give ma'am 5 minutes?
I guess you can watch the live session later on. I don't want to wait for one person. Okay.
Okay, okay, ma'am.
Okay, so determinants. So the next topic is determinants. So what are determinants? So determinant is again a matrix operation. Okay, so when we talk about square matrices, let us consider any square matrix. Then we can associate any square matrix with a number called the determinant. How are we going to define it? First, let us look at the very simple case of 1 by 1 matrix. Okay, 1 by 1 matrix means you are just going to have one real number inside it. So for this, we are going to define the determinant of A as just the number itself. Okay, so what is the determinant of the matrix minus 3?
3, minus 3.
Okay, now let us look at the scenario 2 by 2. Suppose you are having a matrix A with entries A, B, C, D. Now we are going to define the determinant of A as AD minus B.
AD, B, minus B.
Okay, so now
Okay.
for example, if you are going to have 1 minus 1, 3, 0, can you tell me what is determinant of A?
Minus 3. Minus 3.
Plus 3.
Plus 3 or
3.
minus 3?
Plus 3.
Plus 3.
Plus 3.
Plus 3, ma'am.
1
Plus 3.
minus minus 3, so plus 3, right?
Yeah.
Yes, ma'am.
Okay,
Yes,
fine.
ma'am.
So up to 1 by 1, 2 by 2, it is very simple. For 3 by 3, first let us look at one specific formula, and later on I will give you more general formula. Now at this moment I am going to give you one specific formula for finding the determinant of a 3 by 3 matrix. Even for 2 by 2 matrix I have given only one specific formula. You can find it maybe in other ways also. So let us first look at the 3 by 3 case. A by 2 by 2 anyway it is going to reduce to the same expression, but for 3 by 3 it can be several different possible ways. So A, let us say the entries are A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. So the determinant of A is going to be A11 times the determinant of this matrix. What is the determinant of this matrix? Can you tell me?
A22, A32,
A22, A33 minus
A33.
A23 minus A32.
Yeah.
A23.
Okay. Next, I'm going to put a minus and then
Minus
A1.
1.
Now, what is the determinant of a matrix which has the entries A11, A13, A31, A3? A11, A13, A31, A33.
Ma'am, A21, right?
A21, ma'am.
A21, ma'am, right?
Did I see? Now we are having, so we are removing this and this.
First
Okay,
row and
fine.
Yes, ma'am.
second
Yes.
column.
A21, A23.
First row and second column. Yes. A21, A23, A31,
A21 into A33.
Yes.
A21,
Into
A33
A33
A33 minus
minus A23
A33
and A31.
into
A31.
A31.
And then
positive column.
Plus
here
A21,
A21
A21,
A32
A32
A22,
minus
A21,
A31.
A32 minus
minus
A22,
A22, A31.
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 Okay. So this is the determinant of A. All right. So
Yes,
this
ma'am.
is how we find the determinant of a 3 by 3 matrix. So this is one formula as I told you. Now let us try with some specific examples. Okay. So again, something happened here. I guess I scrolled up. Okay. So now in this example, I'm going to consider this matrix. Can you tell me what is the type of this matrix?
6.
Upper
6.
triangular, ma'am.
5.
This is an
Upper triangular matrix.
Upper
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 triangular.
triangle.
triangle. This is an
Upper
upper
triangle.
triangular matrix, right? Fine.
Yes.
Now let's find the determinant of this matrix. What is the determinant of this matrix?
6.
7.
6.
Oh,
6.
7.
six,
Product
ma'am.
of
Just
the diagonal
6.
matrix.
6 minus 0, right? Or
Exact.
plus 0.
Yes, ma'am.
6.
Okay, fine. Okay, now let us consider another example. A is equal to 1, 0, 0, 2 minus 1, 0, 1, 3, 1. What is the type of this matrix?
Lower,
Lower triangular matrix.
lower
Lower
triangular.
Lower
triangular.
triangular matrix.
Okay, I'm just taking some specific examples. We can find determinant for any matrix, any square matrix.
Minus 1.
Minus 1.
Now,
Minus
Minus
one.
1.
according to the
Minus
formula, 1 times of minus 1 minus 0 plus 0 plus 0, right?
And yes,
Minus
ma'am.
0 plus 0
Yes,
does not work.
madam.
Yeah. So what's
Yes,
the
madam.
answer?
minus
Minus
1.
1.
1.
Minus
So
one.
what is that you observe in both the cases?
The multiplication
Product
of
of the
diagonal
diagonal
element, ma'am.
entries.
The determinant is nothing but the product of
Diagonal.
diagonal.
Diagonal
Diagonal
entry.
element.
Okay. So in the case of
Is
triangular matrix, you don't have to use some big formula. Straight away, you have this property that the determinant of a triangular matrix, either whether it is upper or lower, it does not matter. A triangular matrix, what is the answer? Is the product
of diagonal entries.
Diagonal
the
entries.
diagonal entries. Okay. Now, can you tell me what is the determinant of any diagonal matrix?
Product of the diagonal entries. 3.
Yes. Determinant of diagonal matrix is product of diagonal entries because diagonal matrix is also a triangular matrix, right?
Yes, ma'am.
Okay. Now, what about the determinant of any identity matrix?
1.
1. Okay, fine. So now let us look at another specific case. Okay, now let us say you have a matrix like this. So what do you observe? One of the columns is completely 0.
0.
So now what is the determinant of this matrix?
0.
0.
Now suppose if you have one of the 1 minus 1 1 0 0 0 5 minus 7 and 12. What's the determinant of this
0.
matrix?
0.
0.
So the determinant is again going to 0,
0.
right? So from this, what can you observe? That the determinant
Of a row of column.
a matrix with
Matrix.
0 row or column is 0. Okay, fine.
Yes, ma'am.
Okay. Now let us look at another example. Something wrong happening. Okay, fine. A is equal to 1
Excuse me,
minus.
ma'am.
Yes.
Can we continue this in next session, please?
Yes. I will just finish maybe just 2 more properties and then we will finalize. Okay, we will complete this. We are almost done here.
Okay.
Okay, we are almost done. So what is A? A is 1 minus 2 3 1. B is 2 1 0 1. Okay. So now can you compute determinant of A?
7.
Yes.
1 minus plus 6 is 7.
Yeah.
And what is determinant of B?
2.
2.
2. Now can you compute quickly what is A into B?
Yes, ma'am.
14.
A into B.
Determinant is 14, not AB.
2.
So 2,
2.
then 1
1 minus 2
minus 1,
minus 1.
6,
6. Yes.
3 plus
3.
1,
1.
4. Now what is determinant of this matrix?
4 plus 6, 10. 9.
What?
Sorry, 8 plus 6, 14.
14, ma'am.
14.
I understand it's getting late. Okay. So what is that you observe? Determinant of A into B is equal to?
Is equals to
Product
determinants
of
of
determinant
A
A and
into
determinant B.
determinants of B.
Okay. Right. So these are some very important properties for determinant of a matrix. Okay. So we
Yes.
have a few other properties based on whatever we have seen already so far. There is one more important topic which I could not complete the determinant with this, and there is one more definition. So what is left is row operations and the general determinant formula. Only these two topics are left, and both of these are quite simple. So tomorrow you have a TA session. Just quickly, everyone, tell me tomorrow 8 to 10 is the TA session. Do you have some other session before 8 tomorrow?
No, ma'am.
No,
Yes.
No,
ma'am.
ma'am, I think.
Only maths session is more.
Tomorrow
Only
one.
math session is there, ma'am.
Okay, so in that
Only math
case,
session is there.
okay, in that case, can I tell the TA to start the session maybe at 7:30? Is that
Yes,
fine?
ma'am. Okay.
Okay,
Yeah.
ma'am.
Okay. So
Yes, ma'am.
so that first he will introduce what are row operations and give the general formula of determinant, and then continue with the general TA session. Okay.
Sure, ma'am.
Okay,
Sure.
ma'am.
Okay,
Okay,
ma'am.
ma'am.
Okay, ma'am.
Okay then. So I hope today's
Bye,
session
ma'am.
was the topic was clear.
Thank you.
Yeah,
Yeah.
Bye,
ma'am.
ma'am.
Sorry anyway for the
Okay.
confusion in the beginning because of the technical issues here.
Yeah, that is not in your hand, ma'am.
No issues,
So
ma'am.
thank you.
Okay,
Yeah,
ma'am.
that
Thank
is
you for
not
your
in
time.
your hand, ma'am.
Ma'am, do you
Okay.
have
Thank
one
you,
note?
ma'am.
Thank you,
So,
ma'am. Good night.
so
Thank you, ma'am.
tomorrow session will be
Thank you,
from
ma'am.
7.
Okay, ma'am.
Yes, thank you.
Thank you.
Yeah.
See you.
Thank
So
you,
Thank you
ma'am.
for the
if
session.
you have any specific doubts, you can ask. Otherwise, we will wind up the session.
Yeah,
Ma'am,
ma'am.
I haven't
Why
got
do
it.
we
Can you
need
please
to
send it?
study the determinants of a matrix and how does it related with a matrix basically?
See, determinant of a matrix, geometrically there are some views for determinant, but the main thing about determinant is that based on the determinant, you can tell whether the system is consistent or not. Okay,
Ma'am,
so
can you
just if
send the
you,
drive link?
it is there in the Google Sheet itself. If you open today's calendar, also you can find in the find the Google Sheet.
Okay, ma'am.
Okay, ma'am.
Okay.
Ma'am, so tomorrow the session will be from 7:30, right?
Yes, yes, I will update the calendar accordingly.
Okay, ma'am.
Madam, if I wish to draw the column matrix or a row matrix, ma'am, so how can I do that?
If you want to do what?
Draw the column matrix, ma'am. Like I have a column matrix and I want to draw on the line axis. So with three cross one matrix, how can I do that?
You want to draw in the sense, I don't understand.
I want to represent a 3 cross 1 matrix on a line axis, ma'am. Is it possible for me to do that?
Okay, so you want to see, visualize it in R3.
Yes, 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 ma'am.
So if you want to visualize, I suggest better you use either Desmos or GeoGebra for 3D. 2D at least you can just plot X axis, Y axis and plot and see. But for 3D, I guess it's better if you use some tools like Desmos or GeoGebra for visualization. All right.
Yes, ma'am, yes, ma'am.
Okay, okay.
Yeah,
Any other
okay.
questions?
Ah,
Ma'am,
no, no. Thank you so much for myself.
so excuse me, ma'am.
Yes.
So I have a question regarding the system of linear equations. So there was a question asking that there was a unique solution V to the system of linear equation Ax is equal to B. So V is the solution of the matrix X of
No, no,
it is
no.
a
B is the constant vector. B is the constant vector. See, one thing you should this is a common instruction for all the session. If you have a specific doubt on a specific question, particularly from GAP or activity, please ask it in the TA session. If you have conceptual doubts, you ask it here.
got it.
Okay, ma'am.
Okay, so shall we wind up then?
Yeah, sure.
Yeah, ma'am.
Yeah, yeah,
Yeah,
Good
sure,
night.
ma'am.
yeah,
Thank you, ma'am.
sure, ma'am.
Good night,
Okay,
ma'am.
then thank you everyone.
Good night, ma'am.
Thank you so
Yeah.
much.